Hi, welcome back. So in this video, we'll go through mapping in Solidity. Now, mapping in Solidity or any other programming language is essentially the concept of keys and values, right? So where keys will be mostly basic data type like string and int. It can't be an array or struct or complex data structure like arrays, where value can be anything, right? So value can be a single string or it can be a very complex data type such as struct. So what we'll do is we will go through two examples. One is where we have a very simple way of storing data where we'll define a mapping where we'll store a key which will be an employee ID, and uh, we'll store the name of that employee, right? And in the second case, we'll go and we'll try to store more information corresponding to an employee by creating a proper struct. So let me create a mapping first. So we'll have a mapping. Now mapping, the way you declare is you say, okay, the key, what is the type of the key going to be? So in our case, the employee ID is going to be uint, and what values we are going to store. So we are going to store the name of the employee, right? So essentially what we are going to do is that we will be storing the employee ID and the name of that employee. However, here you see that in this particular example, the employee ID can be 1, can be 39, and can be 500. So irrespective of what the ID of the employee is, we do not need to go ahead and declare it as an array and basically block that space around. So mapping gives us that flexibility. So in this case, we just have to add 3 employees credentials. So we'll just be utilizing that much memory itself, right? So now what we'll do is we'll just have a setter function. So we'll have a setter. Now in setter, it is going to be a public function again, and just let me zoom it out. Yeah, so it is going to be a public function, and what we'll do is we'll send the value, right? So our value will be the say employee ID, and we'll have a name. Now name string memory and the name of the employee, right? So what we'll do is whatever the data that is the mapping we have, we'll use the ID as a key, and we'll set the name corresponding to that, right? So here we go. The code is successfully compiled. We'll go ahead and we'll deploy it, right? So once deployed, you see we have two methods now. One is the data and another one is the setter. Now in the data, I can go ahead and I can look for any key. So even if the key does not exist, it will send me something by default, right? So let me try out, say, an employee ID 12, right? So if I try, nothing comes in this string. So in our case, we basically have to add Suresh with an employee ID 1, right? So let me go there. What we'll do is we'll pass the key, which is the ID, employee ID 1, and we'll pass the name, right? So I did the setter, and then when I try to say extract this, I get the name as Suresh, right? However, what if I also have to add more information in that? So maybe which department Suresh belongs to, right? So for that, what we'll do is we'll create a struct, right? So maybe my struct would be called as an employee, right? And say employee will have the name, right? So name of an employee, and then employee will have the department. So I will create a department here. Now in this case, what we are trying to store is that corresponding to any key, which is the employee ID, we'll be trying to store more complex data type, which is going to be struct in this case. So instead of the declaration that we have done here, where we have defined mapping uint string, what we'll do is we'll replace it with the employee data type, right? So now what we are trying to achieve is that not only that we are storing the name of the employee, but also we go around and store its department as well. So for example, I need to add Ruchika under the department HR with her ID being 39, right? So let me go ahead and have this. So we'll be modifying this this setter function, and we'll pass another parameter which will be for department, right? So here we go. So department. So now what we will be doing is, so we'll take this ID still as a key, and now we'll just have to do it like employee and just pass the params. So whatever the attributes is. So the first attribute is the name, right? And the second attribute that we have is the department attribute, right? So yeah, so it's auto compile, so it's successfully compiled. Now I will go ahead and deploy it, right? So now if I so what our aim was that we have to add Ruchika at ID 39. So right now we do not have anything at 39. So yeah, so we have an empty name and an empty department. So now I have to add 39, and I will add the name and maybe add the department address, which is say admin in our case. So I will do the setter, and then suppose if I do get again. So here you go. Against this key value, we now have the name and as well as the department as well. Another important thing that I want to explain is why mapping is important in Solidity, and especially in a blockchain like Ethereum, is that we are able to store, say, users balance corresponding to their address, right? So address is one of the special data type that we have in Solidity, and one can declare it like, say, an address, right? And then maybe it will have, like, for now I will just add it as a string, but it may have like information about all the information about your account detail. So right, so maybe I can declare it as account. Right. Now this address is basically a hexadecimal address that belongs to you on an it's basically an Ethereum address itself, right? So other than that, an important point that I want to highlight is that mapping are always stored in storage, irrespective of whether they are declared in the contact storage or not. So this definitely costs you gas every time you declare it, irrespective of whether you are declaring it as a as a state variable or whether you are declaring it within the function as well. So that's all for mapping, and in the next video we'll discuss more about storage in the memory. Thanks.